Hello everyone. I'm sorry that I've not been able to upload more videos. I was actually busy with other projects, but I still actually value this channel so that we can be able to make each other learn. So now I made a promise in one of my videos that I will be able to help you or to let us learn how to analyze a ransomware using memory forensics. So today is the day that will be hands-on into memory forensics using Volatility framework and other tools in order to get into the analysis of one of the ransomware attacks. If you remember, we had a ransomware attack in 2017 May, which was actually WannaCry ransomware. So today is the day that we will be tackling WannaCry in order to see how actually, as a network engineer or as a network administrator or a cybersecurity professional, how can we actually tackle the memory forensics as part of our incident response, because incident response actually involves memory forensics, which means prior to everything, one of the things that you have to be doing is conducting memory forensics that will actually help you, because investigating computers RAM is actually critical. So now we have we have volatility as well as the image of WannaCry ransomware. Now I think we have these two files that will help each other identify the forensic artifacts that we will get here. I'm sorry to tell you that this video will be long enough so that we are able to cover a lot of things that I think there is a necessity that you will have to watch this video if you are into the blue team or the red team operations. So now let's start volatility so that we can not waste more time. So we have volatility executable, volatility. Let's ask for help here, so we can identify that a lot of plugins and a lot of flags are actually available with volatility. So you can pass them and then try to play with volatility in order to check actually how to use all these plugins. So I will not use each and every plugin for this tutorial, but I will sort of use the ones that actually have helped me into the analysis of this ransomware. So now let's try to do this so that we can volatility and then remove this and then pass F into sample.row and then try to check the type of system that was actually affected and its profiles. So let's wait and see. So we can see that it was Windows XP with Service Pack 2, and it was actually a 32-bit operating system. So because we know volatility uses kernel debugger to identify the profile of an affected system. So now we know the system we are dealing with, so it's time for us to pass the profile here. The profile, let's remove all this. Now the question that we are trying to answer in memory forensics is to identify several artifacts forensically on how actually the system got affected, which processes are actually suspicious, or which actually are malicious processes in the system, so that we can see actually how are they affecting our system or our network infrastructure. So now we will check the list of the processes that were running using the PS list plugin. So now we can identify several lists of the Windows processes that were running at the moment this RAM was actually imaged. So now we can see, okay, I nearly forgot to actually tell you that for you to conduct memory forensics, it is critical that you understand how Windows functions, or an operating system of your target is functioning. So which means you will be able to identify whether this service host.exe is a descendant of services.exe. So that is one of the factors that might affect your forensic investigations, because if you don't understand, it means you will give the court of law false information. So now, to get to it, now it is critical that we can go directly where we actually going. So we can identify a process of task, some sort of task scheduler.exe, but it's not the task scheduler that you know, because a task scheduler is not ending with E here, but this one is 1940 process, which is the result of explorer.exe, which means the parent process ID of this was explorer.exe. So now this process gave birth to this process ID. So these process IDs, these two process IDs, if you are a good forensic investigator, this one and this one, they can demonstrate a lot of red flags, because they are abnormal. These processes are not normal Windows processes, because we know all about these ones except these two. Now we can use process tree, which is PS3 plugin on Volatility, in order to see whether the way or the chain on which these processes have given births to each other, if I can say, if we can use process tree, PS3, so that we can see. Now we can see that these processes, the pattern at which these processes took place on this computer, then there was a random explorer.exe which gave birth to this process ID that ended up giving us the wannacrypt.exe, which is the ransomware that we want. So now what we are going to do, one of the things that you have to know about ransomware attacks is that if you can use a process explorer software, you can see some of the things that I'm talking about. In malware analysis, a ransomware usually pops up and then exits. So which means there are processes that have exited apart from these two processes. So in the previous analysis, we have seen that this ransomware gave us several processes that actually exited. So we need to also understand and know how these processes were looking like, so that we can check. So which means now we can use PS scan, and then try to grab all the processes that are related to the process ID of 1940, which is this one. Now let's try to check. So you can see that they came and then exited. All these processes are the results of the process 1940, but some of them are no more available, which means they are actually exited. So we can see them using the PSX view. So we can see at what time they actually exited. So which means these processes, they took place after the launching of the initial malware. So after that, then the other processes just exited and then left some of these processes, such as this one and this one, which is the first. If I can say, this looks like it was a malware dropper, and the malware which was actually running is this one. So now what we can do now is to clear this. and then try to check. Now that we are able to identify the parent process IDs, the malicious processes that we actually suspect, one of the things that we have to check is the Windows API hooks, or the DLL files that are associated with these two executables, because a ransomware has got some of the DLLs that it might be utilizing that will raise red flags in order to check the functionalities of this ransomware executable. Because in Windows, every software has got the DLL files that it actually depend on, so that it can perform its functionality well. So which means now we can use the DLL list plugin, and then let's try to check with 1940 process 1940. So now we can see several DLL files. Then let's try to go with the 741. So now it's time for us to discuss on the DLL files, some of them that we suspect could be causing some trouble as far as this ransomware is actually concerned. So now let's go. Then we know that some of these DLLs are always available on every software, such as this one, but the one that actually makes us probably suspicious is ability to query the registry or editing the registry keys, which is this DLL file. Apart from that, we can see the Secure32, which is a DLL involved in security or encryption, which means this file is capable of providing encryption service. So now we can also check some other suspicious ones, such as URLmon, which means it invokes the functionality of a certain browser, such as Internet Explorer. And then we can also see that it's capable of creating socket, which means it can now create socket communications that will make us remember that WannaCry was doing some self-propagation in a network. So one of the other things that we have to see is this type of DLL that deals with high-speed network communications. This means that this ransomware was actually controlled by the remote command and control center. So it might be using this one to communicate back home. So now there are pretty as many DLLs that we can check and try to do some deep checking using this volatility, but I was just showing you the basics of what we can actually start suspecting. Now it will be time for us to try to check for the mutex. The mutex, what is actually the mutex? Mutex, what is the purpose of mutex in malware analysis? In ransomware or in every malware, mutex makes sure that the malware runs only one instance, so that it cannot confuse the command and control. It only runs only one single instance. So that is the purpose of a mutex. The presence of a mutex in this malware will indicate to the hackers that the malware is actually active and running. So we want to check whether there is a mutex on this malware. Now, to do that, we will try to check for the handles. Let's check the handles of this yes. Now let's try to check. Yes, so if you can Google this, I'm not online currently, so if you try to check this this mutex, it will demonstrate, or it will show you that it is a result of this process. Okay, so this mutex tells the hacker that the malware is actually active on the system. So now let's try to check for now it will be time for us to check for registry querying, because we have seen that it is utilizing the ADV API in order to do some querying of the registry. So for that matter, what we can do is to also use the handlers the handlers plugin, and then let me check now. Let's see which is the key. So now we are trying to figure out the affected registry keys, so that we can even actually try to dig deeper using the print key in order to get into actually what took place. So let's try to check. Now we can see that in the machine user, this key was actually affected. So we can also, if this was not, if this is not because of this video, I could even go deeper so that we can check what actually took place as far as this malware is concerned. So now let's try to check. Yes, now one thing that we can also try to figure out is the usage of network connections. So let's try to check connections. Yes, some of the things, so that we can see, because we can see that this malware was clever enough so that it cannot reveal the connections. Now I will show you how to try to carve the connected IP addresses that were actually connected to this computer during the capturing of this RAM, without using Volatility framework, but instead we will be using bulk extractor. So to use bulk extractor, we can make directory. I'm sorry, I've got a small influencer here. So now we can pick up this folder. If you can see, and make directory indicators of compromise. So what we will do is to bulk extractor sample.raw into IOX folder. Now let's try to check. So we will be getting all the forensic artifacts using bulk extractor, which means should any malware try to hide itself, but you will still have some other tools that you can utilize in order to get the forensic artifacts from that particular image. So we can use those IP addresses that we get here as indicators of compromise. So now let's try to go into cd into IOX. Now let's try to ls. So let's locate .pcap. Let's try to check the pcap files. No, I didn't want this. Okay. Let's grab packets. Now we can see that there is packets.pcap here. So if we can Wireshark into packets.pcap, so we can identify several pcap files as far as connections were actually concerned. So trying to filter out this will give you the actual IP addresses that sounded malicious. So let's try to close Wireshark now. remember we were actually still in volatility framework. So what we are going to also do is to make directories, to make another directory, so that we can actually dump these processes that we find malicious from this image, so that we can extract them. Remember, if you do this and then try to execute those executables from RAM, they will still run on your machine. So please don't try that. So if you can see the so now let's clear this. So now let's volatility, and then remember that we have two processes now. So we want to dump those processes, so that we, after dumping these processes, we can be able to do some static reverse engineering, or try to do some dynamic analysis, or debug everything that is actually going on your Windows computer. So let's try to use the mem dump. We will dump the process and its memory location, so that we can do a proper forensic analysis. So now let's go to volatility. Let's proc dump P 1940. Then we will use dump dir. So okay, let's implement make directory. We will make this directory and call it access. This is access. So we have got this. All right. Now access. So now it's time for us. Let's try to check. All right. So I messed up here. So which means we will dump dir into the access. So let's try to check. Right. So we've got two processes now. Or remember, okay. So let's take this one, 740, 740, so that we can dump it to the access. So now that we have two processes, let's go to our access directory and then see these are the Windows executables. If you can come here and then open another terminal, so that you can try to file into executable .740.exe. so it will tell you what is actually, so it can tell you what it is. Now let's try to exif tool. Let's try to exif tool into executable.740, so that we can seek for its metadata. Now it can tell you what is actually holding in terms of metadata. Now the same process you can use on this other executable, which is 1940. So right now we have got these two processes, so we have to dump the memory locations of these two executables, which will help us into further trying to analyze this memory, these other executables. So now let's try to remove that. So now let's go to volatility. So now what we're doing, we remove this okay, let me mk directory memory locations. So this will contain the memory locations of the of these executable files. Now it is time for us to remove proc dump, but we use mem dump. So now what we're doing means, so let's do that. Right, so it's written now 740. Now it's time for us to also dump another memory location, which is 1940 into that. Right, now that we've got this, what we can do is to go to our folder and then identify these two DMP files. So we can see these are the memory files and these are the executable files. So if you can go to Gitra and then try to launch this executable, or you can even run strings so that we can see, we can run strings. If you can run strings executable dot 740 dot exe, then maybe grep HTTP, so it can help us, so we can see that how to buy Bitcoin. So there are these references to this HTTPS or these websites, or otherwise you can try to .com if there is a .com, something to do with .com here. Please make sure your computer is connected to the internet, all that stuff. So let's try to cmd.exe. So let's try to check that cmd. Alright, so we can see that there is also cmd here. So otherwise you can also use strings. Now going to strings, so you can find that this had something to do with languages. It used the languages to tell you maybe to pay ransom. If you are in Turkey, then it can translate that into Turkish and give you the Turkish version of their ransom message. So now that we can see as many strings as possible here, let's try to check for, let's try to find onion, something to do with onion. Okay, let's say .com. All right, so if you are into the analysis, you won't take this short time, you will take a longer time. So that is one of the things that we have to know, because there are pretty large amounts of information that you need to be able to analyze this ransomware. So these are actually the basics of what you can actually do into analyzing the ransomware. I think with this I can say thank you very much guys for watching this tutorial. If you like this video, please subscribe, like, share, comment. This will make me make actually more content. So thank you very much guys for watching this video.